Hi everybody, myself Professor Pushpa Navanti. In today's video, I am going to explaining about Kepler's third law of planetary motion and the derivation of the Kepler's third law. So already you are all familiar with the Kepler's first and second law and also the derivation of these two laws. And you are familiar with the terminals, that is the terminology escape velocity and Newton's law of gravitation. So, Kepler's laws of planetary motion. In astronomy and classical physics, laws describing the motions of the planets in the solar system. They were derived by the German astronomer John Kepler, whose analysis of the observations of the 16th century Danish astronomer Tycho Brahe enabled him to announce his first two laws in the year 1609. And a third law nearly a decade later, in the year 1618, Kepler himself never numbered these laws, specially distinguished them from his other discoveries. So this is the terminology of law 3, that is a semi A and B are the semi-major and the minor axis, and T is the time period. So this is an ellipse. There are the Kepler's three laws of planetary motion. The one is the law of ellipse. The path of the planet about the sun is elliptical in shape, with the center of the sun being located at one of the foci. And the second law, an imaginary line drawn from the center of the sun to the center of the planet will sweeps out equal areas in equal intervals of time, and this law is also called as the law of equal areas. And the third one is the ratio of the squares of the periods of any two planets is equals to the ratio of the cube of their average distance from the sun, and this third law is also called as the law of harmonies. So now we have to derive this law, that is the law of harmony. That is, the law states that the square of the orbital period of a planet is directly proportional to the cube of semi-major axis of the ellipse. That is, t square is directly proportional to a cube. A is the semi-major axis and k is nothing but is a proportionality constant. So now we have to prove this law. There is a concept from the proof of first law that is needed, that is eccentricity, and those two formulas are formula 1 and formula 2, that is E equals to or naught V naught square by Gm minus 1, and R is nothing, R equals to 1 by 1 plus E, that is E is nothing but eccentricity, and or naught divided by 1 plus E cos theta. So Kepler says that T square by AQ is equals to 4 pi square by Gm. From formula 1 for area equals to pi AB. Therefore, area equals to integral 0 to T 1 by 2 or naught V naught into dt. Therefore, area is equals to 1 by 2 T. So, the integration of T dt is T, and now we have to substitute the limits, that's upper limit minus lower limit, then it becomes T it or naught V naught, call this equation as 3. So now we have to combining formula 1 and 2 and solving t, then pi AB equals to 1 by 2 t or naught V naught, and make it t equals to, then it becomes 2 pi a square or naught V naught into 1 minus e square. So R maximum is equals to 1 when theta equals to pi. Therefore R maxima is equals to R naught into 1 plus e divided by 1 minus e. Therefore, A is found using the maximum position vector, that is 2A is equals to R naught plus R maxima, then 2A equals to R naught plus R maxima is nothing but R naught into 1 plus E divided by 1 minus E. Therefore, 2A is equals to R naught divided by 1 minus E. Therefore, 2A equals to, now we have to substitute this value of E, then it becomes 2 R naught Gm divided by 2 Gm minus R naught V naught square. So A can be found from 5, that is A equals to R naught Gm divided by, see dear students, a line is missing here, so that is R naught Gm divided by 2 Gm minus R naught V naught square. Therefore 1 by A is equals to 2 Gm minus R naught V naught square divided by R naught into Gm. Now we have to squaring both sides of equation 4 and use 2 and 5. Then it becomes t square is equals to 2 pi e square by r naught v naught 1 minus square root of 1 minus e square whole square. After simplifying, we will get that is t square is equals to 4 pi square e square by gm into 2 gm minus r naught v naught square divided by r naught into gm. Now we have to solve t square, then it become t square is equals to 4 pi square by gm into a cube, or t square by a cube equals to 4 pi square by gm. So this is about the derivation of the Kepler's third law. So thank you.